Packet page 5. Oh boy, I can barely speak. Now we're looking for the angle. And again, that shouldn't be too big a surprise for us, because when we look at these charts, you can see that if you know the ratio, it will tell you the angle. Or like we said with the calculator, if you hit the second key first, right, and then you get the arc cosine, for example, of 0.6947, it will spit out the angle, which is about 46 degrees. You can see there's rounding again. So now instead of the side, we're going to solve for the angle. And I know kids can get a little bit confused in all the algebra of this. I'll do one or two with the trig chart, and then I'll do one with the calculator. Again, I think it's important to know the calculator, just because I don't think they're going to let you use the trig charts on the SAT and that kind of a thing. All right, so as we look, again, we recognize opposite, adjacent, and hypotenuse. We use that because we know that two of the three sides that we use are going to give us the ratio of sine, cosine, or tangent. So we can recognize how to set up sine, cosine, and tangent. Once we know how to set that up, we either go to the table or the calculator, and that helps us get, again, if we have the ratio of the angle or if we have the angle of the ratio. It doesn't matter which. And again, we can do that with the calculator just as easily. Once we've done that, we can actually begin to use those ratios and set it up like J-Rod talked about, so that we can get a solving for a side length. But now we're going to solve for an angle. So what we're going to do, let's just start with the first one. I want to know what's the given angle for S. So again, I'm going to go ahead and mark my opposite side. I'm going to mark my hypotenuse. I'm going to mark my adjacent side. And as always, I'm going to determine, actually I should have written sine as opposite. I should have written SOHCAHTOA, right? So sorry, you're going to have to, and I'll pause. So you can see I do care about the opposite. I do care about the hypotenuse. I don't care about the adjacent. So I'm going to use opposite and hypotenuse, which tells me I'm going to use sine. So let me clear a little bit of room here to go ahead and solve this. All right, so I'm going to use the sine, like we said, the sine of S degrees. I'm trying to get this degree. I don't know what it is, but I know I'm still going to use these ratios. Is going to be the opposite over the hypotenuse. Is going to be 4/10. So I'm going to just go ahead and through this. The sine of S degrees is equal to 4/10. I just wrote the same thing twice. I meant to write 0.4, right? I'm just going to grab a calculator. 4 divided by 10. Now I have a ratio of 0.4. So I want to know what angle that gives me. So I can go second sine and put in my ratio of 0.4, and it spits out, it's about 23.6 degrees. So S is about 23.6 degrees. And right now I'm going to show you one of the benefits of a calculator versus the trig chart. So I have the sine of 0.4. If I go with the sine of 0.4 and go down, you can see I get between 23 and 24 degrees. It looks like it's closer to 24 degrees. So if I'm using the trig chart, I'm going to say my answer is about 24 degrees, right? If I use my calculator, I'm going to say my answer is about 23.6 degrees. So you can see they're both close, but I definitely get a more precise answer using the calculator. But again, I just want you to see using that second sign, that arc sign gives you the degree, or just sort of going through the table until you get to the one that you want. That will do it as well. And again, you kind of estimate that as well. So let's go through and do another one or two of these, and then we will call it good on this video. So if I go down here, let's just choose this one. I want this angle. You can see this is my opposite. You can see this is my hypotenuse, and this is my adjacent. You can see the one I don't care about is my opposite, so I care about the adjacent and hypotenuse. So if I go up here, adjacent and hypotenuse is cosine. So I will say the cosine of x is equal to the adjacent over the hypotenuse. So I'll divide 11 by 23, and I get 0.4783, right? 0.4783 rounded. So what I could do is I could go to my table and look for the cosine of 0.4783. You can see it's way over here. So the cosine of 0.4783, I think it's going to be closer to 61 degrees, honestly. It's between 61 and 62. By the way, this is all rounding, so if you're close, I'm going to give it to you. It's the trig I'm worried about more than the rounding. If you put like anything other than like 61 or 62, I would have marked it wrong. But if it's between those, I will take it. So we're going to say x is about 61 degrees. That's using the table. But what if I use the calculator? I would want to know, what is the cosine of 0.4783? And you can see we get 61.4, so it was a little bit closer to 61 than it was to 62, and that was using the calculator. So it doesn't matter to me which ones you use, that's what we come up with. So that would be page 5.